Yes, so good day, ladies and gentlemen. So today we are going to look at the One Fund Theorem in financial engineering. So under the One Fund Theorem, so we are basically trying to find, again, I'm like in this theorem, we are trying to find the tangent portfolio, where we would minimize our variance, basically our risk, right? So the theory itself might be a little bit too much to yeah, I'm like the theory is easy, but the maths might look difficult, but it's not that difficult actually. So suppose that we have like a feasible set of risky asset, uh, as you can see in this example over here. Let's say you have this feasible set over here. Again, I'm like you have a feasible set of risky asset. There it is. So you are able to draw like many tangent portfolios. Like again, I'm like under the two fund theorem, we said that okay, well, if you want to invest, you can just look at investing in two assets. I mean, like two fund basically. So now we can see that if you are to invest anywhere, whether you're gonna invest here, so you can like you would have low variance there. So any other place you would have like still your variance is gonna be higher than at this point. So at this point, that's what you will call your tangent portfolio, because it's gonna touch the feasible set at a tangent, and that's what we call a tangent portfolio. So basically, as you can see, you will only have one tangent portfolio, and that's what we are trying to find. And this tangent portfolio, it is in such a way that you are maximizing the again, I'm like this theta, the angle of theta. So that is what your tangent portfolio is going to be. So we say that theta is gonna be so theta is gonna be what? So theta can be found in this way. So you are basically, okay, so you basically have to find the gradient, right? So in order to maximize your theta, you have to maximize your gradient, right? So that's all you need to do. So what you need to do is to maximize your gradient. So you have to maximize this thing. You have to find the maximum of the tangent of theta, and that's all you need to do in order to maximize in order to find this tangent portfolio, is to maximize your gradient. So we know that the risk of a risk-free asset is zero, because it's risk-free. So you can have this equation like this. So this is the equation that you can have, right? So if that's the case, this is what you can do. I'm sorry about that. You are able to do this. You are able to see. So you can, because T is a tangent portfolio, right? So that's what you are looking for. You are looking for the tangent portfolio, and this is how you can define it, like the returns of the portfolio and the variance of the portfolio down here. So now we can rewrite this equation in this way, right? Because we know that the standard deviation is basically the square root of the square root of the variance. So we can write the equation in this way, so we can modify it, right? So you are able to say this is the portfolio returns, and this is your risk-free, right? So this is going to be your risk-free returns, right? So you know that this thing, you know that the sum of your weight should actually be equals to 1, right? So that is why it's like this. So every number is multiplied by 1. So basically 1 is the multiplicative identity. So if you multiply any number by 1, you will still get that number. So because we say that the weight, the sum of all the weight is going to be equals to 1, therefore if you multiply the risk-free asset times the sum of the weight, you should get 1, right? So you should get 1. And then again, this is how you can write your variance, the variance of your portfolio. After that, you are able to take it a little bit step further and write it in this way. So you can take out the weight outside. As you can see, the weight is now outside, and then you are able to deal with this equation on its own, right? So from now on, what you need to do is to say, okay, I wanna maximize our tangent portfolio, I mean, like our angle of tangent, and to maximize it, again, I'm like, you would have to use calculus, which is, I'm like, you will have to use the derivative, and then you're going to equate it to 0, right? So you will have to find the derivative of, in terms of weight, right? Because you are looking at the weight. So the derivative of tan of theta. So this is how you are going to find your answer. So we can move to the next page, and this is how it's gonna be, right? So since you have a quotient, so you have like two, again, like you have like a numerator and a denominator, you are able to use the quotient rule that you have learned in calculus previously, and this is how I have tried to simplify it. So you have f over g. So the partial derivative of that in terms of x, you will have g squared, I mean, like, which is the numerator, and then the first derivative of f times g minus the first derivative of g times f, and then that's how it is, right? So you are going to do the same for this, right? So you are going to say this thing squared, I mean, like, you know that if it's gonna be squared, so since you have written it as a, I mean, like, as the square root of the variance, you will only have the variance underneath, and then you will start simplifying the top part, and when you simplify it, this is how this is the answer you are going to have, right? So basically you have this is supposed to be 1 over here, so basically you will have this one squared, it's already squared, so since you can, like, since it has a square root, you just write it as it is, and then you will have and then the first derivative of this in terms of weight is that you will take out the w outside. I mean, like, you will differentiate the w, and then what you will have left is just the return of the asset I minus the risk-free asset, right? And then you will multiply it by in this case by g. I mean, like, we will just call this function g, we will just call this thing like f over g, right? So yeah, so basically this is your g over here. So, and then minus I mean, like, you're gonna find the derivative of that one, I mean, like, of g now, and then the 1 over 2 is gonna come down, and then you're gonna have your, I mean, like, the sum of, again, I'm like, this thing colored over here is basically your f, and then this whole thing is just the differentiation, the derivative of your g, of your function g underneath this whole part, right? And if you want, you may not even have to include the 1 over 2, but then I just include there because it's convenient, and you are able to remember where the equations come from. I mean, like, where it come from actually. So basically this thing is 1 over here, it's not 3, it's 1. Let's see, it's 1, because you will have 1 over 2 minus 1. So basically 1 over 2 minus 1 is going to be equal to negative 1 over 2, right? So that's where it comes from, and you are going to equate it to 0 because you are trying to find the maximum point, right? So you are going to do this for all asset I, for all asset I's, right? So we can take it further and then write it this way, right? So you can multiply this thing by 0. I mean, like, multiply it on both sides, and if it goes to the other side, it's gonna multiply by 0, and then it's gonna turn into 0, right? And then from there you are left with this part. You are left with this part. You are left with this part, and then you can take this part to the other side, and this is what you will have over here. So basically, this is what you have. So you have basically simplified it. That's all I did. You simplified it. And then from there on, this is what you can do. Okay, I just wrote it down as it is, like, from previously, so that you can see it down, right? So you can see it as it is right now. What you can do is to divide both side, you can divide both side by this thing, by the standard deviation, right? So if again, so you will basically have the standard deviation times the standard deviation, which is gonna give you the variance, right? As you can see in the next page, what you will have is basically the variance, because you have found the standard deviation and then you can find the variance. So what you'll have as an answer is going to be your variance, right? So the standard deviation times the standard deviation would give you the variance, and then you would have that equation over there. So as you can see, you have Ri minus Rf as a subject of the formula. So now what you want to do is to group these two things together. You can group these two things together, right? Because already you are able to, not necessarily that you are able to, but then you can group them together so that you are only left with the covariance matrix over here. You are only left with the covariance matrix over there, and this is the resulting equation in the next page. So this is going to be the resulting equation. So this is after you have let, if this thing is going to be your lambda, let's say this part is going to be equal to your lambda, then you can write it in this way. You can write it this way, right? So that's how it is. You can write it in this way. Again, don't forget, this is for all asset I. So you're going to do it for each individual asset I. What is happening here basically is that I am simplifying it. I'm trying to simplify it. So like I said, there's just a lot of numbers, variables just flying around, but then it shouldn't be that difficult to understand again, right? So after that, I can write it in this way. I can just swap where they are, and then since I am looking at this for each asset I am able to write it as a matrix form, right? So in the next page, you can see it in a matrix form. This is how it's gonna look like in the matrix form. So now you can see, again, this thing looks very familiar now, because previously we also had like a covariance matrix, right? So as you can see, this thing is gonna be your covariance matrix. This is gonna be your covariance matrix, and this is gonna be your weight. It's just that your weight now has lambda in them, right? So it means that this weight, it's basically this weight is basically going to be anomalized. So that's what we call anomalized weight. So you can just say it's going to be V1 all the way to Vn, right? You can just call them V1 up to Vn. And what do I mean by it is anomalized? It means that the sum of that weight is not going to give you 1, because you are going to multiply it by a constant. And since it's not going to be equals to 1, you would have to add them together in order for you to normalize them, and then you can divide by like each weight Vi by the sum of all the weight, so that you can make them equals to 1, right? So another contrast that you should take into consideration is that on the other side, you no longer have the returns only. So basically you have the return premiums. So is the return in excess of the risk-free returns? So that is your return premium. So yeah, so your weight is normalized. So now we can try to recap. So basically what were we trying to do? We were trying to find the tangent portfolio. That portfolio, such that this line, which you will call line L, I'll just call it line L, L1, where it touches the feasible side at a tangent. And we are only going to look at the upper side, because we are trying to find the most efficient portfolio. So we only look at the upper side. So we want to try to maximize our return. And there's only one place where we can have the risk-free return and the portfolio T, where which fall on the same line, which is line L, and that is at point T, right? So you already have the risk-free return, so you need to find point T, and this is how you're going to find point T. This whole equation over here will help you find point T. So next time, if they want you to find the tangent portfolio, this is the equation that you are going to use. Unless if they ask you to prove it, then you will just follow the steps that I just did. But then if they ask you to find the tangent portfolio, this is the equation that you need to use, right? Do not forget that this thing over here is just a normalized weight. The weight is not normalized, so it is not equals to 1. So you would have to make it equals to 1. Another contrast that I will have to emphasize on is that you have the return premium no longer. Again, I'm like, no longer do you just have the returns, but then you have the returns in excess of the risk-free asset. So yeah, I hope this video has helped you a lot in understanding more about the One Fund Theorem, because now under Two Fund Theorem we told you that you only have to find two funds that fall on the efficient frontier. Now we say that, okay, you have to find the risk-free asset. Now if you include the risk-free asset, you are able to find fund T such that it's going to maximize your return even further, right? For any given risk, or maybe you can say for any given risk, you are able to find the maximum returns. And in order to do that, you will have to find the portfolio T, which is gonna be called your tangent portfolio, and we will learn more about it in under cap M. What is this T? Yeah, I hope this video helped you a lot. So if you did like it, please subscribe and follow me, and stuff like that, and comment, such things.